guys remember Ben and Arthur? I think you guys remember Ben and Arthur. Way back from C20, watch this now. Remember C21? Remember Ben and Arthur? Watch this. Boo! Hold up here. What's going on with this? Hold up. We saw this little story about a week and a half ago, I think.
This is what we're talking about. It's a mathematical explosion. Einstein said that compound interest is the eighth wonder of the world. Now, compound interest is simply this. You take your money down to the bank. Let's take this $1,000, and we take it down to the bank, and we put the money in the bank. Now, you leave it there, and it earns interest, and you leave the interest there. The next year, you earn interest on the $1,000 and on the interest. The next year, you earn interest on the $1,000, on the interest, and on the interest, and you leave it there again. The next year, you earn interest.
So right now, when he describes the two brothers, those accounts that they're putting money into is an annuity. Okay? It's the type of account where you periodically put money in, and it's growing in a compound interest way. Watch.
Interest on the $1,000, on the interest, on the interest, and on the interest, and then you leave it there again. That's what compound interest is. The trick with investing is you got to start, and you got to start right now. You got to get started. So we're going to get the $1,000 out of the way. We're going to get the emergency fund built as quickly as we can. We're going to get you out of debt, and then we're going to get you investing as fast as we can in these baby steps, because time needs to be on your side. Let me show you what I'm talking about. Let's look at Ben and Arthur for a minute. Ben starts saving money at 19 years old. He saves $2,000 a year. He does that all.
Okay, so right there on the left, at 19, every year he's putting $2,000 into the account. Okay? At 19, he put $2,000, and it grows at $240. The interest is $240 on the right. When he's 20, another $2,000. So it's $4,749. Okay? What on the right side is the principal plus the interest. On the left side is just what he's putting in every year. 21, okay? And notice by the time he's 26, okay? At 26, let's see, 1, 2, 3, 4, 5, 6, 7, 8. What's 8 times 2? He's put in $16,000 by the time he's 26. Because look at 2,000 times 8, that's $16,000. But notice, look at the interest how it's growing from 26 to 27. From $27,000 to $30,000. That's almost like $3,000. So the interest is growing more than the $2,000 he's putting in. Let me say that again. Look at from the 26th to the 27th year, when he's from $27,551 to $30,857. That's over $3,000 of interest. It's grown. So the $3,000 is more than the $2,000 he's putting in. So he stopped putting in $2,000 at that point. He doesn't need to put any more money, because the interest is outdoing what he's even putting in at that point. This is an annuity. The catch is you can't take the money out till the annuity is, the contract is done. And annuities will the time frame and interval, that's between you and the banker and you and the finance officer when you open up your annuity. But this is how people allow their money to grow from them. And this is how retirement accounts work. You're going to put in so much money every year, and you're not going to touch it till you retire. You can't touch it till you retire. That's why it's growing so fast. Because the bank who's taking your money is using that money and investing in other places. They're lending it to other people. and they're doing the stuff that they wanna do to make money with your money. And so the contract is, you're gonna put in so much money, you're gonna have this big old massive sum, but you can't touch it until then. But you could borrow from it. You come a rainy day, you need some $5,000 quick, you can take $5,000 from your account, you just gotta pay it back within a certain amount of time. Cause it's your money. But you can't take it all out until the annuity contract ends.
But why do you have to pay it back, like, if it's your money?
Because the contract is, they're gonna pay you interest. See, let's say I'm the banker. I'm gonna pay you interest, but you're gonna give me your money for 30 years. Are you willing to give me your money for 30 years? If you are, I'm gonna pay you a nice sum at the end. But in that 30 years, you can't be touching the money you're giving me, because with your money, I'm doing my thing with your money. I'm investing over here, I'm related to this person, that person. You see what I'm saying? So it's a business deal.
What if there's like an emergency or something, like you really need money?
Okay, got you. So at that point, you can take it out of your money, but there's gonna be a heavy tax on it, and a penalty. So let's say, so that's a good question. So he's bringing up good questions. What if, like, you come across a death in the family, you need to bury somebody, you need 10 grand or whatever? That's a good question. Then at that point, there's parts of the contract that say, okay, we're gonna give you your money, but you're gonna be heavily penalized, so we're gonna keep a good portion of it, and you're gonna be taxed. The tax animal wants some of it too. You have to pay some taxes on it, because it's part of your income for the year.
So then like you make a deal like for how long?
Yes. See, sometimes people do a 10-year annuity, 15-year, 20-year, 30-year. So that's between you and the finance officer. You see? So it's all a business transaction. So let's see what happens with Ben.
All the way up until age 26. At age 27, you will notice Ben puts in 0. Say 0.
Again, why? Well, because the interest is outdoing his 2 grand. He's making 3,000 just on interest. He could stop putting money in. It's like a snowball now. It's crazy.
At 27, he quits putting money in, but he's got the pump primed. The snowball is there. It's starting to roll down the hill, and every time it rolls over, it picks up more snow because it's a bigger ball each time it rolls over. Then his brother Arthur on the other side, he looks up and says, ooh, Ben's saving money. I need to save money. He starts saving money at age 27.
So his brother's jealous. He starts at 27. Arthur does. Ben's been saving 2 grand up to 26, and now his brother's, okay, I'm going to get into on this action. 27, watch this.
Now, let's fast forward all the way to the end of the story at age 65 and see what happens. What happens is, at the end of the story, Ben has put in $16,000, and
so, remember, Ben stopped putting money in at 27, so the amount of money he put in was only $16,000. He stopped. But look at the end when he's 65 years old, he's got $2,288,000 in that account. Arthur, he's been putting in $2,000 till he's been 65, so he put $78,000 in this account, and he's made $1 million, $1.5 million. That's still a good amount of money. $78,000 to $1.5 million? That's a huge jump. That's like a no-brainer. That's good. That's like, let's see, 78,000 is that's like 20 times the amount of money. $1.5 million is 20 times the amount of 78,000. But notice, the point here is time. You got to start early if you want to make a lot of money. Is his point.
and has ended up with $2,200,000. Arthur, who put in $78,000, only ends up with $1,500,000. The guy who put in $78,000 later ends up with $700,000 less than the guy who put in $16,000 earlier.
It's all about time.
Some of you are looking at that and going, "That's a real nice chart if I was 19. Well, let me tell you this. If you're in here and you're under 25 years old and you grasp what I just showed you intellectually, to the point that it drops from your brain into your heart and changes your behaviors, I just made you a multimillionaire.
In other words, saving is the name of the game. Saving money. Not getting all happy because you got a paycheck and just starting to burn it on stupid stuff. You gotta learn how to save. Anyway, annuities, here we go. Here's the annuity formula. Get ready. Write this down. So we already know the compound interest formula. This is very similar. Let me write this down. It's right here. And again, we're going to let the calculator do all the work. The only thing new about this formula is FV and AD. And an R you're already familiar with from that formula. It's the same thing. Go ahead and copy that down. Here we go. So future value, how much money is it going to be at the end of the annuity? Amount deposited right there. So there's a big fat numerator. Look at AD times, look at, there's a bracket, so there's two parentheses, a bracket right here, and then a parenthesis inside the bracket. So there's like a double onion, so to speak. You know when you unwrap an onion, you got an onion and you got a layer outside the onion. It's kind of like that's what's going on here. You have the outer parenthesis, which is the brackets, and then the inner parenthesis right here. Okay, so it's not a big deal. We'll just put those into the formula using our Desmos calculator. The Desmos calculator can do it all. Rate, that's the same thing as that. The annual interest rate is the numerator. Number of periods compounded per year is the denominator. We're used to that. We've been doing that all week. And same thing with the nth power. Look at it right there. Okay? So that compound formula, the compound interest formula is actually built into it because it's an annuity. That's how the money grows so quickly. Let's try one example. Papel. Let's get some papel up. Here we go. This is actually number 1, not number 2. You invest $3,000 at 4% compounded quarterly. What is your future value after 2 years? Wait. That's actually not it. Cross that out. Forgive me. There we go. This is the one. Forgive me. Cross that out. That was just a normal interest. That was a normal compound interest formula example. Go ahead and write this one down. You invest $300 monthly to an annuity for 20 years at 5% interest. What is your future value after 20 years? So you're going to leave in there for 20 years. What's your future value? Is that the compound interest formula, not this. This is for next week, but we're starting it right now. Just getting a foretaste of what's going on here. All right, so let me go to write down the formula. The formula is, here we go. Just remind myself. AD 1 plus, okay, go. Let me copy and paste that puppy. Here we go. All right. So the amount deposit, notice, let me shrink this a little bit here. Some area to write. Okay. We are good. So the future value, see, what is your future value? At 20 years, how much are you going to have after 20 years? So I'm just going to follow the formula. Future value, here we go. Future value is equal to the amount deposited, parenthesis, but the big parenthesis is like a bracket because you're going to have parentheses inside it. And then look at what we have. Here's, doesn't that look familiar? Plus 1 plus r to the nth power. That's the compound interest formula we've been working on the whole week. Minus 1 though. Close that bracket. All over r. It's not that big of a deal. You're already used to the compound interest formula. This is just a compound interest formula on steroids, so to speak. But we're going to let the calculator do all the work, right, Valencia? And we're going to earn our R stamp by putting your phone away when I have the floor. It's all fun. Here we go. Let's rock and roll. The future value then is the amount deposited. How much am I depositing every month? Well, $300. Bracket. 1 plus the rate. Now remember, the rate is a fraction. The numerator is a percent, has a decimal, and this is how many times it's compounded per year. So, what is the interest rate here? 5%. So it's going to be, the rate is a fraction all the time, so it's going to be 0.05 divided by how many times compounded each year? The interest is compounded monthly. That's why I entered that last sentence. The interest is compounded monthly, so every month it's snowballing with interest every month. So that's 12 times a year. To the nth power, so the n is number of years times the number of periods per year. So we already know it's 12 periods per year. And we're going to leave this money in there for 20 years. We're not going to touch it. So that's 20 times 12 power. You get that from percentage? Minus 1, close that bracket, all over 0.05 over 12. Because r is the same thing. Remember, r is still a fraction. It's 0.05 divided by 12. The rate's always a fraction. It's the annual interest rate divided by the number of times compounded per year. Nice. So that's a nasty, nasty looking fraction. So what I'm going to do is, let me go ahead and clean this up a little bit. 20 times 12 on a calculator, let's see, what is 20 times 12? That's going to be, I'm going to simplify the exponents, 240. So it's the 240th power. So look what I'm going to do. The 20 times 12, I'm just going to change that to the 240th power. This way I can type it nice and neatly in my calculator, and this is still a minus 1. Whew, that's no joke. Look at that thing. That's going to tell us how much money there's going to be in there after 20 years. Here we go. Here we go. Here we go. Here we go. All right. So watch me enter it in. So 300. There's the amount deposited. I don't have any brackets, so I'm just going to do parentheses for now. But this bracket is that parenthesis, so I'm going to put another parenthesis now for this one right here. Right here. Watch how I do it. So I'm going to put another parenthesis. Maybe go back a little bit. So notice how the first parenthesis gets a little bit bigger, which is fine. So that big parenthesis serves as my bracket. The smaller parenthesis is now I'm right here where the 1's at. So let me put the 1 plus the rate is 0.05 divided by 12, right? Let me shut that parenthesis. Okay? minus 1. Actually, I forgot to do the 2/40th power. To the 2/40th power, so I'm pressing the exponent button to 2/40th power. And now I gotta get out of the exponent mode, so let me click to the right of it to get it out of the exponent mode, okay? Because it'll still keep typing exponents. Minus 1, okay? Let me shut the parenthesis now, boom. All that divided by 0.05 divided by 12. Let me put the division, boom. Look at that, does it for me. 0.05 divided by 12. Rocking and rolling. There's the future value of the money. $123,310.10. $123,000. 123,000. So 123. 310 and 10 cents. So she's putting in $300 a month for 20 years, and it turns out to be $123,310.10. That's a good deal. That's a really good deal. Let's see here. So $300 times 12 times 20. So if it didn't grow interest, if she just saved $300 under her pillow for 20 years every month, she would have made this much. Saving $300 a month without any interest for 20 years, this is how much you'd have. But instead, with the compound interest, she has that much. It's almost twice the amount. If that got to $140,000, it'd be double the money. But it's almost double the money because she left it in the compound interest annuity. It's powerful stuff. We're gonna go into more examples on Monday. Tomorrow's a quiz day, and the quiz is gonna be just on this. I'm gonna give you the rest of the period to start your flip grid on this. On the flip grid, just press play. I tell you what to do. You're just gonna tell me what the variables mean, and you're done. Okay. And that's your DMT. The problems, I'm gonna save till Monday. So I'm gonna erase the problems. Your DMT is just a flip grid. And then work on anything else you owe me for the rest of the period. Prepare for tomorrow's quiz. Hit it.